before we move on to this next section, I just want you to take a look at some of the different applications of the derivatives, which are rates of change of distance over time, which is velocity, rate of change of population of bacteria over time, and these are all very useful in different fields such as economics, medicine, and physics. So the next section is all about derivatives of inverse functions. And this is in section 3.6. The objectives of this section are find the derivative of an inverse function and differentiate an inverse trigonometric function. Let's just quickly recap the property of an inverse function, which is that two functions are inverses if they are symmetric about the line y equals x. And because they are symmetric, what happens to the x and y coordinates such as AB, they flip, and for the inverse function, that becomes BA. So let's take a look at my first example here. My first example deals with evaluating the derivative of an inverse function. So when we are evaluating, we're actually finding a value. But before we do that, I would like to take a look at this problem first. The first task that you will need to do is first to find the value of f inverse of 3. So you're given the function 1/4 x cubed plus x minus 1. You're asked what is the value of f inverse of 3. What that means is we're looking for the value of x when y is equal to 3. Now, just by inspection or just by guess and checking, we can see that f of 2 is equal to 3. And so, the value of f inverse of 3 is equal to 2. Another way of finding this is by the use of a calculator, either by looking at the graph or looking at the table.